So let's try out working with these trigonometric functions along with rules that we learned about in previous videos. So finding the derivative of f of x equals 5x cubed times sine of x. So I put my multiplication symbol right there. I'm going to use the product rule. So taking the derivative, I'm thinking of that derivative of 5x cubed, and then multiply that with keeping sine x the same. And I'm going to add on keeping 5x cubed the same, and then multiply with the derivative of sine x. So that'll be 15x squared times sine x plus 5x cubed times cosine x. Just applying our derivative of sine of x, which is exactly equal to cosine of x. And we could leave it like this. Some good practice would be looking for greatest common factors that could come out. So we could divide out a 5 and an x squared to leave us with 3 sine x plus x times cosine x. Doesn't change much here because there's nothing to cancel out, but just for the sake of practice, we could leave it in that factored form. Okay, next one here, we have cosine of x divided by 4x squared. And with this one, I'm going to use the quotient rule. So taking the derivative, I'm going to go low d high, so 4x squared times the derivative of cosine x minus high d low, so cosine x times the derivative of 4x squared all over low low, so 4x squared squared. Okay, so 4x squared times the derivative of cosine of x, which is negative sine of x. So I'm going to bring this negative out front and then multiply sine of x right there. And then minus derivative of 4x squared will be 8x times cosine x. All over 4 squared is 16. X squared squared is x to the 4th, multiplying those exponents. All right, what I'm going to do is take out the greatest common factor in the numerator. And let's see, I'm going to take out 4. There is a negative 1, but that's not really going to help me here because there's nothing negative in the denominator. So I'm going to factor out a 4 and an x. And that'll leave me with negative x sine x minus 2 cosine x all over 16x to the 4th. And then I can see 4 divided by 16 will leave me with a 4 in the denominator. X's cancel to leave me with 3 in the denominator. So my derivative is going to be that negative x sine x minus 2 cosine x all over 4x cubed. All right, some more examples. So we have the derivative of 2 times cosine t times sine t. How about call this 2 cosine t times sine of t? And with that, I can see we're going to use our product rule. So taking the derivative, I'll take derivative of the 2 cosine t, keep sine the same, plus keep the 2 cosine t times the derivative of sine t. Okay, so derivative of 2 cosine t will be a negative 2 sine t, and then that's multiplying with another sine t, plus 2 cosine t times derivative of sine is cosine. So we're getting a 2 cosine squared t plus, nope, minus 2 sine squared t. Now, a common mistake that comes up here is seeing cosine squared and sine squared. You like to think, ooh, Pythagorean identity, we can make a substitution. Not with subtraction between them. With subtraction between them, we're going to be stuck just like that. We could factor out a 2, but that's about as far as we could go there. All right, let's go to this cosecant x plus x times the tangent of x and taking the derivative. So we have 2 terms here. I'm going to focus on that derivative of cosecant x and then a separate derivative of x tangent x that I'm adding together. Okay, so derivative of cosecant x from our previous page, that is our negative cosecant x times cotangent x. So that right there is just our derivative of cosecant of x. And then we're going to add on, and for x tangent of x, we're going to need to use the product rule. So derivative of x times tangent of x plus x times derivative of tangent of x. So all of that right there is coming from our second piece. So we'll have negative cosecant x times cotangent x plus the derivative of x is just 1, so that's a tangent x, plus x times the derivative of the tangent of x, which is secant squared. And really there isn't anything we can combine there. Something I would maybe do is, I'm just realizing I left an x out there, is possibly switching everything into terms of sine and cosine and see if anything nicely combines together or simplifies or cancels. I'll let you know I did that in my notes already and it didn't make it look any better. So with that, we're just going to leave it like this. But that is an option for trying to simplify things, is you can always switch all of these back into terms of sine and cosine to see if things will simplify in a nice way.